In this video, we are going to solve the numerical question from chapter number 4 and 6. So the title of the chapter is Newton's Law of Motion, and the sixth chapter is Momentum, Impulse, Conservation of Momentum and Collisions. So only few problems we are going to solve from these chapters. Let's start. The first question, a 5 kilogram bucket of water is raised from the well by the rope with a constant upward speed as shown in the figure. So the figure is given here. Find the force of tension exerted by the rope on the bucket. Consider the acceleration due to gravity. G value is 9.8 meter per second square. So here the information is given based on the bucket of water, and you are just raising this bucket by using the rope. So by that, what will happen? The tension will be generated in the rope. So that means if you want to draw the free body diagram, I have the tension force here, and then the force due to gravity is here. So if you want to find the value of the tension, you have to write the equation upward force, which is equal to downward force. So upward force is our tension, and the downward force is the force due to gravity. So the force due to gravity is nothing but mass multiplied by acceleration due to gravity. Now I'm going to substitute the value here. The mass of the bucket is 5 kilogram multiplied by the acceleration due to gravity value is 9.8. So if you multiply 5 with 9.8, 5 multiplied by 9.8 gives you 49. So the answer for the first question is 49, and the unit for the tension is Newton. So this is the answer for the first question. In the second question, a crane lifts a car of mass 800 kilogram upward with a constant acceleration of 1 meter per second square as shown in the figure. So the diagram is given, the picture is given here, and here the crane is lift the car by using the wire or a rope. So the upward force generated in the wire is the tension, and the downward force is the force due to gravity. And the most important thing, when you lift the car in the upward direction, it has the acceleration of 1 meter per second square. So you have to find what should be the tension created in the cable. So you have to write the equation. So from the free body diagram, we have to frame the equation. So the most important thing, the net force, which is equal to the mass multiplied by the acceleration. As we already studied in Newton's second law, the force which is equal to mass multiplied by acceleration. So here I have to frame the equations based on this diagram. So tension, my upward force, minus my downward force, which is nothing but the force due to gravity, which is equal to mass multiplied by acceleration, because we have the upward acceleration of 1 meter per second square. So you have to equate this equation by using Newton's second law. Now we are going to find the value of the tension. So I'm going to move this mass multiplied by gravity to the right hand side. By that, the equation will become tension, which is equal to mass multiplied by acceleration plus mass multiplied by acceleration due to gravity. So here m, the mass is the common term, so I'm going to take it out. So I'm going to write the remaining thing, which is nothing but the upward acceleration plus the acceleration due to gravity. Better I can write the given first. The mass of the car here is 800 kilogram, and the upward acceleration is 1 meter per second square, and the value of the g we already know, which is 9.8 meter per second square. Now I'm going to substitute all this value in this equation. Therefore tension, which is equal to 800 multiplied by 1 plus 9.8. So 800 multiplied by 10.8, which gives you the answer of 800 multiplied by 10.8. So the answer is 8640. 8640, and the unit is Newton. So this is the answer for the second question. In third question, they give the free body diagram of the block, and the forces acting on the block is given here. Now we have to read the question word by word. A force F, which is equal to 10 Newton, is acting on the block of mass, which has the mass of 2 kilogram, placed on the rough surface as shown in the figure. So that means the surface is not smooth, it has the friction surface as shown in the figure. If the coefficient of frictions, the kinetic frictions mu k is 0.30, find the acceleration of the block. So that means if a block is moving in this friction surface, by the time it has the friction force, and in these questions they give the value of the coefficient of kinetic friction, and also they give the value of the mass of the block. Now what you have to do, when the block is moving in the horizontal plane, horizontal surface, it have the acceleration, so we have to find the acceleration value. So better we have to frame the equation from this free body diagram. So here the upward force is normal force. Better I can write normal force, okay? And the downward force is the force due to gravity. So if you want to find the normal force, my upward force, which is equal to downward force. So if you want to calculate the normal force, my normal force, which is nothing but mass multiplied by the acceleration due to gravity. If you substitute the value of the mass, what's the mass of the block? The mass of the block is 2 kilogram, and the g value is 9.8 meter per second square. So 2 multiplied by 9.8 gives you 2 multiplied by 9.8 gives you 19.6 Newton. So this is our normal force. Now we have to find what should be the acceleration. So if you want to find the accelerations, so you have to equate these terms. My rightward force, which is equal to my leftward force. Am I right? So my rightward force, which is nothing but the force you applied on the block, minus the force due to the friction, and here the friction is nothing but based on the kinetic friction, which is equal to mass multiplied by acceleration, because we have to use our Newton's second law for finding the acceleration. Now I'm going to rearrange this equation in terms of acceleration. Therefore, acceleration, which is equal to force minus my current divided by mass. Now we have to use the formula for the kinetic friction, as we already studied. The kinetic friction formula is given by mu k, which is nothing but the coefficient of the friction multiplied by the normal force. So now we have to substitute the value here. So therefore the acceleration, which is equal to force minus mu k multiplied by Fn divided by mass. Now I'm going to substitute the value. Therefore A, which is equal to my applied force, is 10 Newton, minus the coefficient of the kinetic friction is given as 0.30. So 0.30 multiplied by my normal force here is 19.6 divided by the mass of the block is 2 kilogram. Now please use your calculator. So therefore 10 multiplied by 0.30 multiplied by 19.6 divided by 2 gives you the answer of 29.4. Here 30, okay. Zero 0.30 multiplied by the normal force is 19.6, which gives you 5.88. Okay, 10 minus 10 minus 5.88 divided by 2 gives you the answer of 2.06. What's the answer? 32.06 meter per second square. So this is the answer for the third question. Let's read what is given in the fourth question. So in the fourth questions, again, they give the free body diagram. So you have to consider how many forces acting on this block. So let's read the question. A block of mass M, which is equal to 5.8 kilogram. What is the mass of the block? 5.8 kilogram. And this mass is in the inclined plane, which is making an angle of theta 25 degree. So the angle of the inclination is 25 degree above the horizontal as shown in the figure. Using a force of magnitude F, which is equal to 32. So you're applying the force on this block is 32 Newton, and find the acceleration of the block if the incline is frictionless. So now we have to see this picture. This inclination, this inclined plane is the frictionless surface, and you have the block of mass. You apply the force of 32 Newton, and by that, what will happen? It is a frictionless surface, so the block will have the acceleration. So if it is a frictionless surface, the acceleration will be there. Because the surface is smooth, so the acceleration will be there. Now we have to frame the equation. So you have to equate these equations with respect to the Newton's second law. So I have to equate, because the acceleration only in this direction, mg sine theta, and this is our normal force, and this is the force due to gravity, and the x component of the force is mg cosine theta, and the y component of the force is mg sine theta. Here the acceleration is only in the sine theta direction. So I have to equate this term. Therefore, F, my rightward force, minus mg sine theta, which is equal to mass multiplied by acceleration. Now I have to rearrange this equation in terms of acceleration. Therefore, F minus mg sine theta over mass, which is equal to acceleration. Now I'm going to substitute all the values in this equation. Therefore, my acceleration, which is equal to my force here, is 32 Newton minus the mass of the object is 5.8 multiplied by 9.8 multiplied by sine of 25 degree divided by the mass of the block. So I'm going to work out here. So I just write 32 here, and I'm going to multiply this 5.8 multiplied by 9.8 multiplied by sine of 25 degree gives the answer of 24.02. 24.02 divided by the mass of the block is 5.8. So now what should be the answer? So 32 minus 24.02 divided by 5.8 gives you the answer of 1.376. So the answer here is 1.376, and the unit is meter per second square. So this is the answer for this question. Clear? Understand? So now we have to go for the fifth question. Read the questions very carefully. What is given in the question? A block of mass M, which is equal to 2 kilogram. What is the mass of the block? The mass of the block is 2 kilogram, and it is on the inclined frictionless plane, which is making an angle of theta, which is equal to 30 degrees. So what's the theta value? It's 30 degree as shown in the figure. The block is released from the rest. So if the block is released from, that means the initial position is in the top. So what is the initial velocity? The initial velocity here is 0. Am I right? So better I can write the initial velocity here, because they clearly mentioned initially the block is at rest. So 0 meter per second at the top of the plane, where the distance from the bottom is d, which is equal to 10 meters. So here from the bottom to the top of the block is exactly d value, which is equal to 10 meter. So here I'm going to write the distance as delta x, which is my distance, which is equal to 10 meter. Now we are going to answer the first question. What is given in the first question? Find the magnitude of the acceleration of the block and the normal force. As we already studied, if you have any object in the inclined surface, if you place the block here, this is your upward force, and this is the force due to gravity, and this is your mg cosine theta. This is your force due to gravity, and this is the mg sine theta. So my upward force, normal force, which is exactly equal to mg cosine theta. So now I'm going to find what is my normal force. What is the normal force? My normal force, which is equal to mg cosine theta. Now I'm going to substitute the value. The mass of the block is 2 kilogram, and the acceleration due to gravity is 9.8 multiplied by cosine of 30 degree. So 2 multiplied by 9.8 multiplied by cosine of 30 degree gives the answer of 16.97. 16.97 Newton. This is my normal force. And we have to find what is the magnitude of the acceleration also. So if you want to find the magnitude of the acceleration, because the acceleration it's in the mg sine theta direction, so I have to equate this term in terms of in the direction of mg sine theta. So therefore the answer for the second part is mg sine theta, which is equal to ma. I can calculate, I can just cancel this mass both left hand side and the right hand side. So therefore my acceleration, which is equal to g sine theta, and the g value is 9.8 sine of 30 degree. So 9.8 sine of 30 degree gives the answer of 4.9 meter per second. What's the answer here? The acceleration value is 4.9 meter per second square. So we completed the two answers in the first question. Am I right? So we find the normal force as 16.97 and the acceleration is 4.9. Better I can write this value here. What is our normal force value? Our normal force is exactly equal to 16.97 Newton, and the acceleration here is 4.9 meter per second square, because we are going to answer the second part of the question. What is given in the second part of the question? How long does it take the block to reach the bottom? Because it has the distance covered d, which is equal to 10 meter. Am I right? So here, how much time it's needed to reach, to cover this distance? And also you have to find what is the speed just as it gets there. So how much, what is your velocity? What is your speed? They ask you to calculate what is your speed. Now I'm going to use the second equation, the equation for motion with constant accelerations. We already studied the second equation. What is our second equation? Delta x, which is equal to v naught t plus half at square. So here, what is the initial velocity of the block, initial speed of the block? When the block is at the top, what is the initial speed? It's 0. So anything multiplied by 0 is 0. Therefore, the delta x, which is equal to, here delta x is nothing but the distance d. Okay, so delta x, which is equal to half at square. Therefore, my time square, which is equal to 2 multiplied by delta x divided by the acceleration. Therefore my time, which is equal to, taking square root on both sides, so therefore this equation becomes t, which is equal to 2 multiplied by delta x over acceleration, and here our delta x is exactly equal to d, which is 10 meter. I'm going to substitute the value t, which is equal to square root of 2 multiplied by 10 divided by our acceleration in the first part of the question is 4.9. I have to write it here. So therefore my time value here is square root of 2 multiplied by 10 over 4.9. What's the answer? 2.02 seconds. What's the answer? 2.02 seconds. So this is the answer for the time. So this much time it takes to cover the distance of d, which is equal to 10 meter. And then we have to find the speed also. So I'm going to use the first equation. We already know V, which is equal to V naught plus AT, and we already know our V naught is 0 because it is initially at rest. Therefore, the final speed V, which is equal to acceleration. What is our acceleration? 4.9 multiplied by the time just before we found us 2.02. Therefore, 4.9 multiplied by 2.02 gives the answer of 4.9, 9.89. What's the answer? 9.89 meter per second. So this is the answer for this question. So in the fifth questions, we have 4 answers. The first answers you have to find the normal force. The second one is acceleration, and the third part is the time, and the fourth part is the speed. So we have to form 4 answers in these questions. Sixth question. The sixth question is based on momentum, impulse, as well as the law of conservation of momentum. So we have to answer this question from that chapter. A boy hits back a basketball of mass 0.5 kilogram. So what is the mass of the ball? The mass of the ball is 0.5 kilogram as shown in the figure. The initial velocity of the ball before hitting his hand. So initial velocity is here given as minus 20 meter per second, and its velocity after rebounding is 50 meter per second. So what is the final velocity? It's mentioned as 50 meter per second. Calculate the impulse. We already studied 2 formula for the impulse. The impulse formula is I, which is equal to the average force multiplied by time, and also we studied I, which is equal to change in momentum. That means the impulse, which is equal to change in momentum. So we know what is the formula for the momentum. So impulse change in momentum, which is equal to mass multiplied by V final minus mass multiplied by V initial. So if you take mass as a common, V final minus V initial is the answer for the impulse. So I'm going to use this equation. Therefore, I, which is equal to mass multiplied by final velocity minus initial velocity. I'm going to substitute the value. So mass of the ball is 0.5 kilogram, and the final velocity is 50, minus of my initial velocity is minus 20. So I have to write it like this. So therefore 0.5 multiplied by 50, minus into minus become plus. So 50 plus 20. So 0.5 multiplied by 70. So 0.5 multiplied by 70 gives you the answer of 35. It's the answer. So the impulse I, which is equal to 35, and the unit is kilogram meter per second. So this is the answer for this question. Question number 7 is related with the conservation of momentum. So we have to frame the equation. Let's read the question. A baseball player places a 50 kilogram pitching machine at rest on the frictionless frozen pond as shown in the figure. That means it's a machine which will give the ball to the player. Am I right? So the machine fires 0.15 kilogram baseball horizontally at the speed of 36 meter per second. So what is the machine mass? Better I can write the mass of the machine. What is that? The mass of the machine. I'm going to write mm. Okay, the mass of the machine is 50 kilogram. And then this machine fires a 0.5 kilogram ball. So what is the mass of the ball? Mass of the ball mb, which is equal to 0.15 kilogram. And what is the speed of the ball? The speed of the ball v of ball final, am I right? Which is equal to 36 meter per second. And what is the recoil velocity of the machine? Because once the machine shoot the ball, the machine will have another velocity because it is placed on the frictionless frozen pond. So the velocity of the machines we are going to find. So what is the velocity of the machine? What is the speed of the machine? So that I can write velocity of the machine, velocity of the machine final, we don't know. So I have to frame the equation because initially this machine is at rest. So I have to frame the equation based on law of conservation of linear momentum. Initial momentum, which is equal to final momentum. So I have to frame the equation. So in this machine, the ball is also there. So initially the machine is at rest. That means the ball is also at rest. So I have to frame the equation. The mass of the machine multiplied by the initial speed of the machine. So V stands for speed, its M stands for machine, it is the initial speed, plus the mass of the ball and the initial speed of the ball, which is equal to the mass of the machine multiplied by the speed of the machine final plus the mass of the ball, the speed of the ball final. So that means we are going to find what should be this value. And now you have to substitute the value here. Initially, this machine is at rest, so the speed of the velocity of the machine and the velocity of the ball is zero. Am I right? Because the ball is inside the machine, so its velocity is zero. So this term is also become zero. This is also become zero. So we have only two terms on the right hand side, and we are going to find what should be this value. What is this? This is the velocity of the machine final. So you have to rearrange this equation. So mass of the machine multiply by the velocity of the machine final, which is equal to, when you move this term to the left hand side, becomes minus mass of the ball and then the speed of the ball final. So we are going to find what should be this value. Therefore, the velocity of the machine final, which is equal to minus the mass of the ball, the velocity of the ball final divided by the mass of the machine. Now I'm going to substitute the value. Minus, we have to write what is the mass of the ball, which is 0.15, and what is the velocity of the ball, which is 36 meter per second, divided by what is the mass of the machine, 50 kilograms. So I have to calculate 0.15 multiplied by 36 divided by 50. What's the answer? 0.108, and already we have a negative sign here. So what is the recoiling velocity of the machine? The recoiling velocity of the machine is minus 0.108 meter per second. So this is the answer. Here. Read the questions very carefully. A golf ball of mass 0.5 kilogram occurs a speed of 80 meter per second from rest. So that means what is the mass of the ball? The mass of the golf ball is 0.5 kilogram and it occurs a speed of 80 meter per second from rest. So that means what is the initial speed? The initial speed is 0 meter per second. What is the final speed? It's 80 meter per second. When hit by the force of 200 Newton. So when you apply the force of 200 Newton to this ball, initially the ball is at rest, and after you hit, how much speed it occurs? 80 meter per second. Now, how long was the club in contact with the ball? That means we are going to find what's the time. So as we already know what is the formula for impulse, because we studied the impulse I, which is equal to the average force multiplied by delta t, and here the impulse is also change in momentum, because impulse momentum theorem we already studied. So I am going to write this equation as change in momentum, which is equal to the average force multiplied by delta t, and here we are going to find the value of delta t. Therefore delta t, which is equal to delta p over the average force. Now we know the formula for change in momentum. So mass multiplied by V final minus V initial is the change in momentum divided by the force. Now I'm going to substitute the value here. Therefore delta T, which is equal to the mass of the ball is 0.5 kilogram and the final velocity is 80 and the initial velocity is 0 and the average force is given as 200 Newton. So when you work out, what's the answer? So the delta T value is 0.5 multiplied by 80 divided by 200. So the time is 0. What's the answer? 0. Actually, this is, oh sorry, the ball mass is 0.05. Am I right? Ball mass is 0.05. So what's the answer? The time is 0.02 seconds. So this is the answer for the 8th question. So delta T. So this much time taken by the force to reach this speed of 80 meters per second. Now we have to answer the fill in the blanks. So please read the questions very carefully before you answer. The Newton's second law states that the acceleration of an object is dash proportional to the net force acting on it and dash proportional to the mass. So we have to write the formula for getting the answer, as we already know, which is equal to ma. So that means the acceleration, I'm going to rearrange this equation in terms of acceleration. Therefore, acceleration, which is equal to force over mass. That means the acceleration has the direct relation with the force, and the acceleration has the inverse relation with the mass. So we can easily answer. So that means the acceleration of an object is directly proportional to, what is the answer? Directly proportional to the net force acting on it and inversely proportional to the mass. The second question, the frictionless force acting between the object in rest is known as, we studied two friction force, static friction force and kinetic friction force. So during the time of static friction force, the object will not move. So what is the answer here? Static friction force. And the third question, the change in momentum of an object is known as impulse, because we studied impulse, which is equal to change in momentum. Actually, this is a theorem, impulse momentum theorem. So the answer for the third question is the change in momentum, which is known as impulse. And the fourth question, the principle of conservation of momentum states that if objects collide, the total momentum before the collision is equal to the total momentum after the collision, because initial momentum, which is equal to the final momentum. The fifth question, the dash on an object is equal to the rate of change of impulse. So we already studied this formula, am I right? That means the answer is the force, the net force on an object. What's the answer? The net force on an object equal to the rate of change of impulse of that object. Now we have to do this match the following. So please, brother, whatever the things you studied in the theory, you have to apply it very carefully. Friction force. What is the friction force here? Friction force always opposite to the motion. Am I right? And the momentum formula, we know momentum, which is equal to mass multiplied by velocity. So the answer for the second question is this. And the normal force, if you have an object in the horizontal, the normal force always perpendicular to the surface, and the net force, which is equal to 0 in x-axis, net force is equal to 0 in y-axis, which is exactly says the object is in equilibrium. So this is the answer for these 4 questions. So please connect the questions with the correct answers, and please go through the theory what we studied in the class. Thank you.
If you like my video, kindly subscribe my channel, share the link to your friends, and like my video.